This is a graph from a science exam showing the output power from two wind turbines, Y and X. This shows the importance of understanding how a scale works. We might be mistaken in thinking this scale goes 0, 1, 2, 3, 4, 5, but then we see that 5 is over here. This little video is looking at the importance of a good scale and understanding how a scale works. This looks like a nice simple scale that goes up in ones, 71, 72, 73 and so on. But how can we be sure? We need to look at the difference between the two amounts given here. So the difference is 80 take away 70, which is 10. Then we need to see how many little jumps there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the total is increasing by 10 in 10 little jumps. So each little jump is worth 1. So the scale does read 70, 71, 72, 73 and so on. One way of checking this is to continue counting right up until the next marker. 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. So it fits. This one's a more interesting scale as it clearly doesn't go 50, 51, 52. How do we know? Because we can keep going on round until the next number. 50, 51, 52, 53, 54, 55. But this is 60. So how do we work out this scale? Again, we need to find the difference between these two numbers, or these two numbers, 40 and 50. So from 50 up to 60 is a jump of 10, and it goes up in 1, 2, 3, 4, 5 little jumps. So again we need to do 10 divided by the number of jumps, which is 10 divided by 5, which is equal to 2. And so this scale goes up in twos. 50, 52, 54, 56, 58, 60. And as before, when we get to the next number on the scale, it should work. Let's try it with 60, 62, 64, 66, 68 and 70. So this scale is going up in twos. Now this is an interesting one because it jumps from 20 to 25, which is an increase of 5, but in 10 little jumps. So we need to do 5 divided by 10 to see which each little bit is increasing by. So each little increase here is 0.5 or a half. So the scale reads 20, 20.5, 21, 21.5, 22, 22.5, right up to 25 here. Let's look finally at a thermometer scale. On this side, the scale is going from 0 to 10 in two little jumps. So each jump is worth 5. So it goes 0, 5, 10, 15, 20. And on this side of the scale, between 40 and 60 is a jump of 20 in 1, 2, 3, 4 little jumps. So each of the jumps on this side is also worth 5. So this scale goes 40, 45, 50, 55, 60. It's always a good idea to check the scale that it works between that one and the next number. Back to our wind turbines. If we were asked to work out the speed of the wind when it first starts to produce power, we would be looking for this value. So how do we read this scale? It clearly doesn't go 0, 1, 2, 3, 4, 5, because 5 is over here. So let's use what we've learned. We need to look at the difference between the 0 and the 5, which is 5, and then count how many little jumps there are, which is 10. So what is each little jump worth? It's worth 5 divided by 10, which is 0.5. So this scale reads 0, 0.51, 1.52, 2.5, which is halfway between 0 and 5, and after 2.5, 3. So this value is 3. Let's mark the scale in twos just to check. The way I've marked the scale now, it goes from 0 to 5 in 5 jumps, so each one should be worth 1. So it should go 0, 1, 2, 3, 4, 5, which was the same answer as we got by going 0, 0.5, 1, 1.5, 2, 2.5, 3. What about the scale up this way? Well, it jumps from 0 to 200 in 1, 2, 3, 4, 5 steps. So each step must be worth 40. So it goes 0, 40, 80, 120, 160, 200. And as I said before, the scale works. If I wanted to find out the maximum value for the power for wind turbine X, I need to go across here and I need to read this scale at this point. But I know that it goes up in 40s, so I will go 800, 840, 880. So that maximum power is 880. But I'll check it by going 880, 920, 960, 1000. So you can see the power, the maximum power for wind turbine Y is 1000. The maximum power for wind turbine X is 880.